Polygons. We're going to work with area. Now, up until now, we did find the area of rectangles. Rectangle is a polygon, a rectangle. And we found out that the area equals length times width, and we did quite a few problems with that. We have other polygons. We have triangles. We have parallelograms, which is like a squished over rectangle. We have a square, which will be the same as a rectangle, only all the sides are equal. And then we have something called a trapezoid, which has two parallel sides that we're going to call bases. I'll tell you that again later. Trapezoid. It reminds me of a triangle with the top chopped off. But you'll pay attention to the parallel bases on this one. And I think that's it. We have another page of finding the area of circles so that we can review that also. But this, you understand, is not a polygon. By the definition of polygon, it has to have straight sides. Okay, but we're going to be finding area of all of these today. So use your formula chart. You will get the formula chart on your test. You cannot take the one that you've made notes on, but you will have one that's the same as the formula chart that you're using in class. So that's why it's so important to use the formula chart here. And it's so important to use the calculator that you'll be using in the GED. So you feel comfortable with both of those. Since we've already talked about rectangles, let's move to triangles. So look on your formula chart and find area. It's pretty close to the top. And then find triangles. Area of a triangle. And let's look for the formula. You will have this available to you in the test. And so the area formula, and I always suggest if you will write the formula as it is on your chart first, and then plug in the numbers underneath, you won't miss something.
I had the wrong one.
The wrong what?
I had the wrong one.
You need a formula chart?
No, I have it.
Okay, no.
No.
I bet you didn't find a formula anywhere, did you? All right, so the one thing that you have to remember about this formula is the height. The height has to be perpendicular to the base. So this is not a height. This is not a height. You'll find out later these are called slant height, and we don't use them very often. We use them in prisms. But the height has to be perpendicular. This means perpendicular, 90 degrees. It has to be perpendicular to the base. This is the base. The height is here, not here and not here. So let me put some numbers on here. How about 12 inches and 8 inches? Okay, and some of your problems may have 11 inches and 9 inches. They may have a lot of numbers that you don't need. So be aware. Close your drive. Let me get it all fixed. Okay. So be aware of which numbers you need to use. This is the base, and the perpendicular line to the top of the triangle is the height. These are the only two numbers you need to find the area of a triangle. So if you write down the actual formula first, then we're going to plug in the numbers that we need. So A equals 1/2, and you know that when they're crammed together, this is multiply. So 12 times 8. Okay, so use your calculator and then you just work it out. Base times height. $48 square inches. Okay, it's that easy to do this. Are y'all okay? Now, there might be some problems, pay attention closely, that they may tell you what the area is, and you have to find the height. That's not hard at all, because if you write this first, then you'll know where your numbers go. And if I'm finding this, it'll be like the X, and you circle it and then just work the problem. Okay, I don't.
Base and height.
The base is
And
here,
then the height.
and this is the height.
Okay.
Okay. Are y'all okay with triangles? I'm going to show you one more that might look odd. It did to me the first time. I remember a lot about high school, junior high. A lot I don't. What about this triangle? Where's the height? I mean,
The bottom one is the base,
this is true.
and then you got to go to the left, right there. No.
Right here.
Yeah.
But if you do that, it's not perpendicular.
Oh, so you got to keep going out until you meet the top side.
So here's the height. Okay, and they'll give this to you. So this is the height. It's like do you see number 5? Actually, number 2 and number 4 are all the same as this. Do y'all see? So don't get mixed up here. And remember, the base only goes from here to here. Don't try a measurement all the way to here. That's not the base. It just goes to here, but then the height is here. Okay? Y'all okay with that?
Yeah.
All right. Let's move on to a parallelogram, which is just as easy, especially when you have your formula chart. A parallelogram is the squished over rectangle. Okay? Now the name comes from this line will always be parallel to this line. This line will be parallel to this line. This line is equal to this line. This line is equal to this line. Okay? And the area of a parallelogram is base times height. That's kind of the same as a rectangle, length times width. However, the reason they use base and height is because this is not the height, just like the triangle. This is slanted. We need the height that will be perpendicular to the base. So this will be the height. This will be the base. They have to be perpendicular to each other, base times height. You notice that this one doesn't have the 1/2 in front because the triangle has the half. This is a parallelogram. You just do base times height. That's the area.
It doesn't matter what side we use.
No, you mean like use this for the base
No, the other corner,
over here?
on the corner, on the bottom. No, because we're not supposed to do that, right?
Oh, like this?
Yeah, are we able to do it like that?
Yes.
Oh, okay.
And what is the perpendicular? It's straight or?
Perpendicular makes 90 degrees. They're lines that create a 90-degree angle when they cross. Perpendicular. Okay, good. Good question. And parallel, you're okay with? Okay. Perpendicular creates a 90-degree angle. Like here. the X and the Y axis are perpendicular to each other, see? Okay. So is this enough about parallelogram? Since you have your formulas, there's probably not a whole lot of teaching here. Now the trapezoid, I want to spend a tiny bit more time on it, but it's not hard either. Trapezoid. Notice I did this on purpose to make sure that this doesn't look like this. It's not slanted the same. This is called a trapezoid. All right. Now I'm not sure how it's written on here, but I'll show you how I do it. Let's see. Oh, where's the trapezoid? There it is. Okay. I'll do it like that does. Okay. The area equals, and the way it's written here, you see it? It's on down in the area stuff. Did you find the formula? Okay. Now it's important to know, of course, now we know about the height and we know about a base, right? We know that the height has to be perpendicular, right? So this is the height. Now, sometimes the pictures that they give you, they turn this around, but what you need to be aware of is that this base 1 and base 2, that's what this stands for, are the parallel sides.
The bottom and top.
Yes, in this case, the bottom and top. But always look for the parallel sides. It does not matter which one you call the 1 and the 2, but these are the bases that you add together. They have to be the parallel sides, the ones that go the same direction. These are not bases. Do you understand? Very important to pick out the right ones, even if your picture's turned a little bit. Look for the parallel bases. So let's just do this one. There we go. And this is 5. We'll do feet this time. Okay. So if you write the formula down first, you just have to plug in everything underneath. It really is the best way to work these problems. 1/2 times 5, because that's the height, perpendicular height, times base 1 plus base 2. Okay? And so we do parentheses first, and this is 20 times 5 times 1/2 equals the area. So area equals 50 feet squared. Remember the squared on the feet because we're finding area.
Where'd you get that? How'd you do that?
Which one?
That's not the 8 plus 12. but
You're
the-
okay here.
Yes, I understand that, but it's going down.
8 plus 12 is 20.
Okay.
Now, what I did to do it in my head,
So you
I
just,
did 1/2 of 20 is 10. Because when it's all times, you can just mix them up.
okay.
So I do 1/2 of 20 is 10 times 5 is 50. But you can
10
also
times
say
20 times 5 is 50.
20 times 5 is 100, then 1/2 of 100.
Okay, that's how you got the 50.
Mhm.
Okay,
Now we can put all of that.
You can do it all in the calculator.
so you're actually minusing them. Like if you do half of,
I won't say yes to that, but if that's how you think about it and get the right answer, I won't argue with you. Okay,
okay,
but there's no minus involved here.
okay,
So I can't say, think of it that way.
okay.
Okay, with trapezoids? Do you need to see any more of them? Okay. Then you have a page or two, I can't remember, that's finding the area of a circle. And if you look for the formula, you have pi times r squared. Now be very careful, because say this is your picture. This is your picture. So you're going to say pi times, but you're not going to put 8 here, are you? Because 8 is the diameter, not the radius. The radius goes from the center to the outside. So this is the radius. So what is the radius?
4.
Yes. So you're going to say 4 squared, and 4 squared isn't 8, it's 16. So your answer would be 16 pi if the multiple choice answers are in terms of pi. If they are not, then use your toggle button on your calculator and find out the decimal. Be like 48 or 49, 50 maybe, 50.12 maybe. I don't know. What is it, Mary?
50.26.
Say it one more time.
50.265.
2615, you said?
No, 5 last. Yeah, 5.
Okay. This and this are the same answers. They're in different forms depending on what's in your multiple choice answers. And you just toggle back and forth in your calculator. Now this is if you use the pi button on your calculator. The only reason you will not use your pi button on the calculator, this is the only time, is if the instructions say, and it's usually in parentheses, use 3.14 for pi. If you do that, you're going to actually put the number 3.14 if they say this in the instructions. If it doesn't say that, use the pi button. That gives the more exact answer. Any problems there? This is just a review of using your formula chart. Let me make sure if I missed any. The only other thing I want to call your attention to, and we worked in detail on it yesterday, is converting your units. Be sure that the units they give you on the figure are the same, yards and yards, inches and inches. If you look back on page, is it the last one I said?
15.
Page 15, it's the last one. Make sure to be aware there that they are different measurements. So you're going to have to convert one of those so you have the same measurements before you can find the area. Page 15. Trapezoids, circles, and then they have mixed shapes so you can decide which formula you need to use. 14 again are mixed shapes. Just decide which formula. And the last one, you need to make sure that you check your conversion of units. Does everybody understand what I'm saying?
Mm-hmm.
Is there any question about today? No? You think you can handle it? Jump right in there?
Gonna try.
I love that. right. Short lesson, but a long time to work on it. I'll be right here.